Hi, everybody. My name is John. I'm a developer advocate here at Arise. So helping put on this agent series that we've been doing, do a lot of our kind of tutorials and some of our video content and events and things like that, just trying to get Arise into the hands of as many people as possible. And that's sort of my whole gig. But Dad, I'll let you introduce yourself before Viva as well.
Awesome. Thanks, John. Hey, everyone. Y'all might know me, but my name is Dat. I'm a solutions architect here. So I build a lot with our customers, kind of on the front lines, but really nice to have you all here for our evaluating agent series. And then I'll let the last person go. This is a dear friend and very influential here in the San Francisco AI community. Go ahead, Vibu.
Hey guys, Vibu here. Nice to always be back with the Arise guys. Love the work you guys do. Yeah, I've done a lot in the scene. So used to do foundation model research, worked as an AI engineer, ran an AI startup, did all that stuff. But evaluating agents, fun topic. I love my evals. So you've probably listened to a talk of mine or something about yapping about evals and how important they are. So I'm excited for this one.
Awesome. All right. And I think we've got a good amount of people. I think we probably get started on some of the content as we jump in here. So yeah, as Vivi said, the topic today is evaluating agents. Before we get into that, a little bit about this overall series that we're doing. We're now on our third session of a 6-session series that we're doing. So you missed the first two. We covered agent architecture as kind of a primer on what makes up an agent, some of those kind of basics there. And then we did a deep dive last week into some different agent frameworks. We also talked about the Copilot agent that we built at Arise, which was a very fun session. So check that out if you missed it. And then today, going through evaluating agents. And we've got some fun sessions coming up over the next few weeks. So next week, we're going to be joined by Tuana from Haystack, who leads the developer relations team over there, to talk through looping and kind of how to avoid loops within agents, or unnecessary loops within agents, I should say. And then we're going to end the series off with a couple different kind of master classes where we have folks coming in. We have Jerry Liu from Llama Index and Xi Wang from AutoGen. May attach a topic to those as we get a little closer, but for now, we're kind of just leaving them as open-end chats. And so keep an eye out for those coming up. And then I'll mention too that we also have this certification that we're putting on where we are kind of combining a lot of the content from this whole series, plus some additional stuff into a general agents certification that we're putting on. So feel free to check that out through the link there as well. Awesome. Cool. And then a little bit of last time before we jump into the content for today. I mentioned last time we talked about different agent frameworks. Basically what we did is we took the first half of the session last time to review an agent that we had built. We built the same agent in pure code, once in LangGraph and then once in Llama Index workflows. And we did kind of a comparison of what that all looks like in those different frameworks. Got pretty in-depth into the code, which is fun. So if you want some technical details on what all that looks like, go check that out. The whole repository is also available too for that, which is fun. So you can follow through the example. And then we had Sally Ann from our product team go through a bunch of lessons from building the Arise Copilot. So that's a Copilot that we built into our Arise Enterprise product. And we sort of talked through the architecture of that and some lessons learned from that process. Cool. And so for today, what we're going to cover is evaluating agents. So now we've talked a little bit about how you can build agents, some of the kind of frameworks involved in that. We're now going to move towards how do you evaluate agents? How do you improve them? What are some of the types of evaluations you can do? How do you break down your agent into chunks that can be evaluated? And then talk a little bit about like traditional evaluation metrics and how those apply for agents as well too.
Awesome. Yeah, so just to pop in here a little bit, let's keep a little conversational. So I'm curious how you guys see, like when do people start to look at evaluating agents? Where is it useful? What are some of the common trade-offs? So some of the stuff that we see, it's like, let's say you need to swap a model in an agent and let's say you've got some privacy centric data and you no longer want to use OpenAI. Well, there's so many steps to an agent, right? There's stuff like you've got, I saw in the previous sessions, you have routers that determine like tool usage. So let's say I switch from like OpenAI's GPT 4.0 to Llama 3. So what if my agent doesn't use tools as well? What if it takes more steps? How do we optimize? How do we evaluate all this stuff, right? So how many steps is it taking to get to the final answer? Is the final answer still good? What point do you guys start to see people evaluating agents? What are like the main things we should look at?
Yeah. Go ahead, John.
I was going to say, at least from the developer side, when I'm working with folks in the community, it's honestly, I see people starting with evaluating the skills and the sort of functions that agents can perform and evaluating those branches. And then evaluating kind of the router and almost like the looping aspect of the agent and the number of steps and things like that is something that I've seen a lot of cases where folks don't even really know to look for that as an area that they can evaluate. And so they tend to go more towards the skills and then only later on start to think through the router side, which I feel like is a little kind of the opposite of what you want sometimes because you can get some of the biggest performance gains and things like that from focusing on the router. So I know that's one side that I see, but Dad, I don't know if you've seen different from others.
Yeah. So if the question is like, when do people start looking at evals? And maybe we'll go through this framework, so I won't go into depth. But I think when people first, like when you think first like prototype something, everyone like vibe checks. I think that's like a normal thing. It's like, what is the output from the agent that I just built? Does it look okay? Then they start to build, and then they'll start kind of playing with it, and or they might build like test case sets, and then that's really when they start looking at evals because they have something to consistently test over. But I do feel like step one is like the moment you build it, you kind of test and play with it. It's just like that natural curiosity as an engineer. And then you might start playing with it and noticing like, oh, it kind of goes off the rails with these questions. You might paste it in an Excel sheet, like, oh, it doesn't do well here, or this is inconsistent, or whatever it is. And then you start crafting like examples. And then from there, you might start to run like evals from there. And then we can go over approaches kind of later about, the granularity of an eval and then the hierarchy of importance with evals. Not all the components are the same, right? So like as John mentioned, you're going to get some pretty amazing, like there's no point in evaluating a component that's part of like some branch or, a downstream path when you weren't supposed to be on that path anyways, right?
Mm-hmm.
So that's the way I kind of think about it. And the answer to that question, it's a very loaded one, Vibo, but I like that you asked it. It just depends on the team and how stringent. Some teams need to move extremely fast, and so they bypass evals, and then that comes back later in some form or fashion as technical debt. And some teams they have to avoid risks. So they have to be very diligent about their evals. But it's a good question.
Yeah, it's kind of like it's another dimension of regular LLM evals, right? So we've got non-deterministic systems where you produce generative answers, right? That's how LLMs are. You have inputs, outputs. But then when you add in agents to the mix, there's, how many steps did it take? Do we need to optimize for latency? How long can an agent run for? So there's also the big AI UX part of this, right? Like a big thing with Devon was their UX, right? The thing can run for 30 minutes, can run for an hour, and you can interject at any step. And these are trade-offs that for different products, you have different use cases, right? So do you want to really optimize? Let's say you're looking at total precision of answering questions, right? So an accuracy-based metric, if you can increase that ever so slightly, but you add in 6 more steps and it takes longer and that affects the UX. So it's kind of like another modality of evaluation, right? There's a few more things to play. So that's where I like your course and kind of how the approach that Arise takes it, where you kind of break it up into different sections and you evaluate them all, and then just holistically, how do we tie all these pieces together? What are the trade-offs, and what do you optimize for, and how does that affect other stuff?
Yeah.
And maybe before we hop into one question for Vibu is like you understand the research side, which is like awesome, and you've also seen the enterprise side. Do you see any differences between like both kind of sets of users? How would you kind of describe both sets?
Yeah, so the research is a lot of, like if you've got code gen and you need to evaluate the steps and try to optimize how long it does and expand this test time compute and everything, you're not as concerned with the end-to-end latency, right? If the thing can run for 24 hours and get the best results, that's great. But in the opposite case, in the enterprise, that often matters a lot more, right? So, the bigger thing there is, can I cut down the number of steps? Can I keep it consistent such that it stays on track? Can I keep it consistent such that I always use the right tool when relevant? So in the research side, it's a lot more like if you've got agents that try to solve bench and whatnot, it's what's the optimal performance outside of the actual use case. In the enterprise side, there's a lot more trade-offs you have to take there, right? Especially when you host these things behind an API and a developer is using them. How do you hand this stuff back off? What's the observability like for this? There's proprietary aspects. So a lot of agents that you use, they won't show you the actual chain of thought, the streams. That's kind of the proprietary secret sauce, right? That's what they've developed that's so good. But on the research side, it's kind of the opposite, right? We want to share, we want to expose how can we get the best. But then there's kind of two trade-offs there. And then evaluating that at some level, it's the same four kind of processes that you have to look at for evaluations, but the trade-offs are very different, right? So if you can, make your application twice as fast for a slight performance hit, that's great for enterprise. But then if you can take twice as long and get a few percent better performance, that's great for the research side. And there's different use cases for both, right? Oftentimes in enterprises, you don't want your agent to spiral for like 20 steps, even if it catches back on track, right? So if it gets stuck in a loop, but it can catch back on after 20 steps, you probably don't want your user to wait that long. But on the academic research side, if we can get an agent to go on for 200 steps and get back on loop if it's off track, that's a huge research, accomplishment. So there's two sides of the same coin, and then it all kind of distills down to practical.
Yeah. The other, I feel like, through line of that is you have to be able to see all that. You have to know what are like, you have to be able to have the observability to see the loops and see the steps that are being taken and measure the latency and all these different pieces. So that's sort of like, you have to have that visibility to weigh into all of those considerations as well.
Yeah. And past just observability, how do you evaluate it, right? So there's often times with an agent when you've got multiple steps, you can get to the same answer in, let's say, 3 steps and 5 steps and 8 steps and 20 steps. If they can get back on track and get the same output. Now, on most evals, if you're, sort of doing a fuzzy match on the output, if it got the answer right both times, well, one time took a lot less steps. For the research side, it's not always as relevant with the amount of steps. We want to push it larger and we want to get it to be able to get back on track. For the enterprise side, sometimes you want more consistency, right? So how do we track for, how do we optimize, how do we fine tune an optimal number of steps that an agent can take to get to something? These are all the new things that you have to consider when you go from LLM evals and observability to agent observability. And then this also goes on the track of, you have guardrails at every step. What happens if an agent breaks 6 steps down through a guardrail, but exposes something you don't want to expose and gets back to the right answer? So it's just another dimensionality of how do we look at observability in eval.
Yeah, awesome. These are all great points. I think we'll keep going, but please jump in as we continue going. And that also for everybody listening in as well too. If you guys have questions or comments or things throughout, feel free to drop them in the chat. We want this to be more of a discussion. We have a little bit less slides today than we had in previous sessions, so we have plenty of time to discuss things as well too. And we want to make sure that we're doing that. So please drop any questions that you have into the chat as well. Cool. All right, I want to do a little bit of a rewind here to some stuff that we showed in a previous session for about like a minute or so, just to kind of get people on the same page in case anyone missed our previous sessions, because we're going to be deep diving into different parts of evaluating agents. Helpful to kind of know at least some typical structures around agents. Won't go through this a lot, but to kind of give you guys a picture or mental map as we talk about some of the stuff. As a lot of folks on the call probably know, as you have an agent, a typical kind of format that you might have here and been using for a lot of the examples is this kind of user input into some sort of router or planner function that's then maybe using function calling, maybe just doing like intent classification or something like that to decide what path to go down out of a set of predefined skills that the agent might have. So in this case, you have like a Copilot agent that can do all these different skills that you see here in this column. And so you've got a router that's choosing which one to go down. Once that skill completes, either we're going back to the user directly, like we saw with our Copilot in the last session, or in some cases, you might go back to the router and then can continue looping through this flow until you get to an eventual answer for that user. So we often have this flow of kind of a router going to a skill, that skill completing, either going back to the router or potentially going back to the user directly, or in some cases, having the agent kind of critique itself and do a little bit of kind of critiquing of its output, maybe cycle through that skill again to have an improved output or something like that as well too. And then sort of continuing down that path until you eventually get to a response per user. And then all the way throughout interacting with different messages or shared state that it can access between different steps of the process.
So to chime in on this slide a little bit, a lot of what we see that separates these agents from traditional LLM calls is they kind of have this planning stage and they have a lot of checks, right? So they'll execute an action, they'll use a tool, they'll get some output, and then often you make another call and you see, is this right? Should I proceed? Should I go back? Did I get a valid response? And this kind of comes into some guardrails, right? So if you've got good tracing, if you've got a good waterfall diagram of the steps that the agent took, all this planning, what it tried to do, if you can pinpoint in where things break in the system, that's often where you can go back. Maybe you can edit a prompt, improve the system. And this is also where you can start to make improvements to performance of agents. So for example, something that you brought up here, John, was like, you might have an LLM call saying like, is this valid? Is this structured JSON? Now, let's say we want to optimize our agent for an actual application. You can start to swap in like, traditional classifiers. You can have like a fuzzy match. You can have a BM25 search. You can swap out some of these LLM calls and start to optimize your end-to-end latency. See how that, it could either take longer and you could swap in other stuff for LLMs, improve guardrails, improve reliability, or, you could speed up stuff and take out calls. So that's kind of one of the big points when it comes to developing agents. You need good observabilities and evaluations of every step, so you know where you can go back in, where you can fix stuff that goes wrong. So for example, let's say like, you've got an agent and you make some changes and it starts to tank performance. Maybe you adjusted the main system prompt and it no longer uses the first tool that kicks off the whole chain. Well, now you can go back in and start to fix that. Maybe that's where you need to add a little guardrail, right? So that's kind of why adding in this observability evals as you build your system right really helps you build a robust, reliable agent. Because the other issue with a lot of these agents is, they work well 1 in 100 times and that goes viral, but they're not robust, they're not reliable. And if you don't have the right mentality on how to evaluate and trace these things, you often don't know how to improve it.
Got it. Yeah, it's a great point. Actually, I'm curious on that note. We have a couple questions in the Q&A as well. This question around how do you monitor LLM costs during the agent running? Should it know, or how can it know to stop before hitting some sort of limit? I guess maybe a question for you, as you're building agents, do you typically have like a limit that's coded in that you'll then track throughout the calls for costs?
Yeah, so it goes both ways. For some certain use cases, like let's say it's a chatbot, one thing that we've seen is like we'll track how many steps an agent can take. And let's say on average across our like golden data set of testing this thing, if it can run about 20 steps before it really derails, that's still probably not optimal, right? If that takes 3 minutes for a response to come in, sure, we can do good UI, UX, we can stream out thought process, let people interrupt it. But sometimes you have to make a conscious choice such that, let's say if it's off the rails and it's tried 3 steps of trying to get back on track, we can manually cut it and interject and say, after 3 tries, give it to a prompt and, tell the user, hey, can you clarify this? And we'll rerun that step and give it some history of it. You have to manage the memory of this. Other times, depending on the application, a pretty common denomination is just 6. So, if it goes past 6 steps, cut the thing and just throw that like history into memory, tell GPT-4, hey, you tried 6 times, you couldn't do it. You suck. Here's what you need to do. And then you kind of go back to the user. But it's all deterministic, And then this is stuff that you probably want to distinguish in your evals, right? So you probably want to turn this check on, turn it off, try to improve it. But it's a good thing to think about, right? It's the right questions to be asking. And then in terms of cost itself, I mean, there were rumors that, Devon's burning $1,000 a minute for everyone using it in their total cost, and they're subsidizing it. And that's the VC model, right? Raise a lot of money, do an expensive product, get it viral, fix it after. But, that's kind of an end user choice as well. And this is where if money is an issue, a lot of like AI engineering methodology that we see is don't try to cost save at first. Use the best system, use the best tools, and distill down later, right? So instead of fine tuning Llama Guard for some sort of guardrail, have an LLM call, use a lengthy chain, use GPT-4o, use the best tools, and as you need to start to monitor costs, see where you can swap out some calls for some lighter models, try to optimize later. But it's all good stuff to track. I hope Phoenix and Arise, I hope you guys track it. I would assume you do. But then that's where the tooling for this stuff comes in, right? So these tools are exposed to you. My general piece of advice is, do the best you can first, optimize later for what you need to optimize. But curious on your guys' thoughts, how it's been with you guys.
Yeah, that was a good transition to Craig's second question, which I think Vibu answered, which was like, how do you track agents' ability to know when they should stop working on something requested that is not available / possible versus continuing to search or work on the task? So I think Vibu kind of answered that. And what I would challenge, like a lot of our audience members, so like here at Arise, we love to go like very engineering, software engineering, like centric rather than like more hype words. But like, I think this design principle, I think product and product design in this space is like super interesting because I think a lot of us, especially from the like software engineering space, are very used to building deterministic systems. So you see these themes of these questions like, how do I do X or Y or Z? I think if you think about treating an LLM as like kind of like a in its own end user, right? Like if you ever designed a product and you realize like you kind of design for your worst product user, right? Like so you kind of have to like, hey, instead of using a free text form where you expect them to be able to answer, like put in the right text field, maybe you just do a drop down. It's like kind of like that thinking. And if like Vibu was giving like perfect tooling for that stuff, so if you notice like, hey, things are going quote unquote off the rails in this section or that section, then you have to really like gate down the LLM or its usage. So you basically treat the deterministic parts of the software deterministically, right? But when we were working with non-deterministic things, just realize you have other tooling for that. So just one like mindset shift I wanted to like encourage like the audience members to really think about. And to answer your question about what we see Vibu in the space in terms of that, I think it's the same exact thing here. I think probably the most advanced folks are doing things like limiting, you can think the number of loops that an agent can do, even letting them know like, hey, X, Y, or Z, like you're on your last like call. And then, but to be very honest, I think that's where the precipice of where a lot of people really are. That's my take, but curious yours, John.
Yeah, similar kind of thing. To be honest, I think you probably run into more folks who are deep down the agent advanced rabbit hole than I do. I get the folks who are building and starting and going. So I think that counting the and limiting the number of retries is essentially what I see most people trying to do, at least as they're getting started with evaluation.
Yeah, and I really like this slide here because if I'm an audience member and the way I think about it is like you have certain Lego blocks that you can build with, right? It's like, okay, do I use an LLM to use control flow or do I use an NLP classifier? What's the trade-off? Latency versus ability to handle complexity. Then you have things that affect the entire system, rather like, okay, how do I manage state throughout the entire system, right? So again, it's very similar to code, just add a new paradigm and that like imagine an LLM or an LLM call or this non-deterministicness as like, think of it as like a user. And how would you gate your users from doing X, Y, or Z? So different paradigm kind of there.
I
Awesome.
do think you should just vibe check a lot of it too, though. Vibe checks are a big part. And we have to remember that not all agents are real-time consumer based, right? So let's say we've got offline agents, right? I want something to go through my inbox, click through every link, get good reports, generate stuff on it. There's a lot of steps there, and I'd go through the same workflow, but I no longer care on how long this takes, right? If it saves me the cost of an EA or my manual hours that I value at whatever, if this thing can run for 30 steps and get back on track and I can run it 5 times with the best model, that's great, right? So we also have to account for that. And latency optimization doesn't always mean swap in a traditional classifier, right? So in some use cases we've seen fine tuning a BART based classifier can outperform an LLM as a judge at the best we can do. We can outperform LLM as a judge, and sometimes we're okay adding these latency steps. And one of the questions here was like, how do you know how many steps is too long or how it's going off rails? This kind of falls back into traditional guardrails, right? So at these steps, we still have to remember, hey, is it hallucinating? Is it making up stuff? Is it going off the rails such that, it's gone incorrect and it's following down a trajectory that's wrong? Is it going down the rails where like, it's used the tool incorrectly, it's got imperfect output, it can't parse a response? So all these things are things that are kind of unique to the pipeline you build, but things that you need to track. And yeah, sometimes you do want to optimize for the other, right? And this is where, yeah, you want the research to blend in, so not everything's real time.
Awesome.
But also vibe check.
Vibe check is the answer. Love it.
We can't say you can eval without vibe checking. You gotta vibe check your thing.
The first
Yeah.
eval is always vibe checking it.
Yeah.
Cool. Yeah, just to kind of level. So we talked about this as a previous example before, but if we're taking a chatbot example, just to kind of put this in people's minds, I'm going to skip through this one and show you guys this flow here of a slightly more complicated agent that is, again, you get your router and then multiple different skills that you could go to and a lot of different kind of things that happen down each of these pathways to make those skills come to a result that someone can use. And so when we talk about like what we're evaluating, we've talked a lot about this whole idea of kind of the agent progressing through different steps and routing and like the path that it takes. And so that's one kind of axis that you could do evaluation on. There is another two of evaluating the skills themselves. Are they giving you the response that you expect? So say you've got a RAG skill that an agent has or a RAG tool that it has access to. Evaluating, making sure that that tool is working properly is one of the other steps that comes up with this as well. And on that note, actually, there's another question that we had too, which is how many tools available to an agent is too many? Should an agent be able to pass multiple tasks or requests to other agents and wait for a response before continuing? I'm curious if you guys have an opinion on how many tools is too many. I know we've built quite a lot into our Copilot. So I know that we have, I think, 15 or 20 or something like that that are in there, and that's still working properly. So I don't know if you guys have a strong opinion on the number of tools to pass to an agent.
Ooh, that's an interesting question. Like there's no right or wrong answer to this one. The answer is always it depends, but maybe it's like, what are some of the methodologies I can understand? I think if you just like, well, one, if you have tools that are not meant for some specific outcome, you can measure this thing, right? You could just measure the counts of certain tooling calls over time. But very interesting question, like how do you know if you have too many tools? Or if like maybe the question is like maybe you have tools that are very similar and then the like your control flow or maybe if you're using an LLM is calling the wrong tooling because they're very similar. That brings you down a rabbit hole of like, well, are you semantically defining the tools well enough? Um, yeah, is it just because you haven't semantically defined them and the LM doesn't understand which tool to use when? But I feel like you could ask the same question to a human and get the same kind of answer. But the question, I would look at that question data driven wise and say, hey, what tools are actually being used and are they being used properly? And then from there, you can kind of like prune tool usage. But I would say, yeah, you can't, I would start with too many and maybe work your way backwards. If that makes sense, if you can get like one tool call to work and then you kind of add on more, but curious to know y'all's thoughts.
I would say the opposite. I don't know if you want to start with too many. I think of the analogy of like, let's say you're asked a question on history and you're given a full library, right? So go find the book. You have thousands of books and find the paragraph for me, right? I'd rather have three books that have the right answer. So, if I've got a basic question, does this part of the agent need access to web search or, a tool that's about a database that's about like my marketing budget? If it's an agent that's just like, writing code, probably doesn't need access to like my marketing HubSpot, right? So you can confuse these systems by giving them more than they need, but that doesn't mean that there aren't times when you need a lot of tools, right? So that's response there was pretty correct as well, where you really need to look at it systematically. Like, is it using the right tool at the right time? Is it not using tools? Have you got good verbose descriptions? Are they diverse descriptions? So, TLDR, it might be a skill issue. Get good at prompting, get it to work well. And like, if you run into issues, if it's using the wrong tool, can you fix it? Should the tool be there? Do it well. Judge your system based on how good of a system you've made. Don't always overload it. So could be skill issue, be a good prompt engineer and check it. And then the other research answer is there's like papers that go into tool use, function calling, optimal tool use, scaling up to like tens of thousands of tools, and where's the DK and where does it use the wrong tool. And then you can optimize this and like you can build a whole check system. You can build a per use like optimality check as a guardrail. So if you want to do that, but you should get good and vibe check it and then look at statistics or go the full out way.
Yeah, and then one piece of experience when we were building our Copilot, which is like AI to observe other AI systems. Sometimes though, when you hand someone a hammer, everything looks like a nail. So we definitely came across where we would like give it three functions to call tool-wise, and well, we gave it one or two, and sometimes it wouldn't necessarily call. Well, when we gave it one function, it always wanted to call that one function. But as we started adding more, it started to choose a little bit more. And we realized exactly what Vipu said was like our descriptions were really kind of horrible at the beginning. But yeah, I mean, the right answer would be add the perfect amount of tools, but that's hard to kind of come to.
So
Yeah.
this is one of the reasons why I'm not the biggest fan of frameworks because they don't explain this too well. You can add a tool, add a multi-agent, give it a one-line description, and then you got 10, 20, 30 tools because, yeah, you just have Hammer. You can just add another tool, add another tool. But then you don't have the tracing to see, you might have added a tool that seems like a useful tool and it never got used or it always fails at one and your description isn't verbose enough. So, you know, some of these frameworks are good to start, but then I'm more in the camp of rebuild it from scratch with proper observability tracing and then evaluate the tool usage because tool usage often makes or breaks an agent. It's where things get stuck, loop out, and try to fix because it couldn't use a tool, it couldn't parse an output, it used the wrong tool.
Mhm.
And the frameworks, they're not. I haven't found a great abstraction for a lot of these, but yeah, that's how I think about it.
No, that's a really great point. And I want to highlight something to like the audience that I don't know if y'all think about too much. It's like you have parts of your system that are like deterministically used, like tool calls, right? It's like the payload coming in, the payload coming out. It's really the connection of like non-determinism to deterministic parts. I feel like that's where like most of the magic is with people who build good, like viable agent products. It's like knowing that you have parts of your like system that don't produce the same things consistently using things that require kind of structure, I think is where kind of some of the magic is. But yeah, plus one to that.
And it actually becomes more of an art and not a science again. So there's some cases where inherently LLMs can complete tasks, right? So if you've got a calculator tool, if you've got, a sandbox IDE to verify code, and every time it properly executes this code, it spins up a sandbox, it runs it, it checks out, that adds some time. But let's say all you're doing is basic, like, data analysis agent, and it's just writing basic NumPy. If instead, you swap that out for a little LLM as a judge instead of this complex tool, well, you might have made your system a lot faster for some basic tasks. So you have to make that trade-off, right? If you've hooked it up to the web, if you've got a RAG database for basic questions it might know, it's a trade-off of agents have more steps, they're slower, you're adding more chains to the loop, and you got verification. Now, do you care about that level of performance, that level of guardrail where it's grounded, or can you skip it and can you do it a different way? Do you need the tool? Sometimes you don't, sometimes you do. This is where it becomes, task based on what the agent's trying to do. What's the real like what's on the line here, right? Is it like a medical co-pilot for a doctor that's doing surgery? Is it just, like a middle school co-pilot for like, introductory to fifth grade Java that they just want it quick and they don't want to close the tab. So you got to make that trade off.
That's good points. All right, I'm going to keep us going a little bit, and we'll come back. There's a couple more questions in the Q&A we should hit on as well too. But I want to go through a couple more here and cover a couple baseline things for evaluation, and we'll dive more into some of those questions as well. So as we kind of get into the structure of evaluating agents here, one of the biggest difficulties that comes from observing what agents are doing, and this kind of goes back to your point earlier, Vivo, on frameworks, is just around the level of abstraction that comes from some of these frameworks. So this code you got on the left here is a LangGraph code snippet to create an agent that has a Tavily search tool that it can use to search the web, has a kind of ability to search for over Phoenix docs. You're defining it in 20 lines, pretty quick kind of run through of an agent here. And then at the same time, one run of that agent gives you all of the steps that you see here, plus more, because it's just going to continue scrolling down. So you can already get a sense that frameworks make it easy to create a lot of these agents, but then they obfuscate how much happens behind the scenes. So having observability is one of the biggest things to kind of start with here, so you can just see what's going on in an agent, especially if you're building with a framework, but even if you're building solo as well.
I'll give some pushback here too on
Yeah.
observability platforms. So directly at you guys, but also all the other observability platforms. So frameworks are an abstraction for building agents. Observability platforms are an abstraction for your observability and your evals and what they trace. And sometimes you don't want an overflow of information, right? Like your diagram's pretty, but I don't love it. I want specific things that I monitor. And sometimes you have to think outside the box, right? So when you use a specific observability tool or platform, and I do like Phoenix and how you guys have abstracted it, it's one of the better ones that I've seen. you don't want to have to fall into the trap of this is all that I'm logging, this is all that I'm tracing, this is, this is something I didn't see. If there's something that you see that's useful to trace that, observability guys haven't thought about, add it in, do it yourself. So, observability eval tools are also an abstraction for how defaults work. But if you've got a really use case that's not standard, it might be better for you to switch off. But to start, definitely recommend them. These guys think a lot about it.
And
Yeah.
that's what we have our manual instrumentation for as well, that you can add on. So if you find something that we're not tracking that you want to track, you do have the option to add it in, I will say. But it's a good point, Phil.
And we're open source, so build it, make it better.
Yeah, yeah, or just add to it. Yeah, that's it. We always love contributions. Cool. So yeah, one of the biggest difficulties is the visibility aspect, and then the other piece is that like you can get an agent that is giving responses, but those responses might be very bad or might get to what you want. You might have the full kind of example of like really kind of failure responses that are still kind of no errors in your program or things like that, where you might get things of an agent unable to answer questions, tools failing, something like that. But a lot of times these won't surface as errors, they'll surface as just sort of bad responses. So this is probably the kind of thing that you're catching with the vibe check a lot of times, I will say, if you would use your strategy there. But I think even beyond that, you might get responses that are still not pulling the right information back from tools, or you might lose information along the way. And if you don't have visibility into what's happening at each step, then you have no idea where some of these responses came from as well.
So I put this back in skill issue. You shouldn't be vibe checking, I don't know, or failed to parse API. If you build a decent system, there should be some level of guardrail, whether it's an LLM call, whether it's something that matches output. Just because you get a response, if the responses couldn't parse API, you do have to be a little clever with it. So the vibe check is a lot of these should not make it through and should be considered a fail. But the tricky part with non-deterministic systems is, sometimes it says I don't know, and that's the right answer because, maybe the agent doesn't have the right information. Maybe you've asked a question that it doesn't have access to, and the right answer is I don't know. So these are where evaluating these things starts to become pretty interesting, right? So when it couldn't parse the API response, what if you've connected it to, your own internal API and your API is bugging out? Your agent's fine, this thing is bugging. You got to vibe check and see, oh, it can't parse my API, but actually my API is kind of broken because it's some, non-public facing API and it's got issues because it's found a way that, you don't use it, but it's come to an answer and it's found an issue in your API. So this is where it goes from your system, get good, build it so that it catches most of these, and build it good such that, when they're right and accurate, they should still make it through. When they're wrong, like yeah, they should get caught.
I'm laughing every time Vivu says get good. I just see like GET, GUD. But I think he's absolutely right. Like I think, yeah, it's like there's so many things why things could go wrong. And this is where like putting in the work with your agent, right? Like it really matters. And like there's so many like spectrums of gray here. It's and like knowing your system super well.
Yeah, and I think it plays into the UX a lot, right? Like failed to connect to vector DB could mean three things. One, your agent failed and it's bad. You should get good. Two, like your vector DB might not be up. So your agent performed well. Your vector DB has issues. Maybe someone's deleted the database. Maybe something's changed up there, right? Your API key expired. Now, three could be it's a good AI UX system, right? If Devin tells you I can't connect to the vector DB and you reply back, try again, it might do it, right? So like sometimes when I use ChatGPT and it's like, I don't know, I'm like, it's okay, you could try again, think step by step. Or, it could tell you like failed to connect, here's why, and you could correct it, right? So like that's not always the end line where you want to kill a system. That's once again your gut check for how your system performs. But it could be like I couldn't connect to the vector DB and I tried this, and you could just tell it, oh, you use Chroma, I'm using Pinecone, you're stupid, try again. And, it works. So it's all judgment calls at the end of the day.
Yeah, and I mean, the important thing to call in there too, though, is you have to be able to know where did the issue come from? Was it my agent messing up? Was it my vector DB has actually had some issue? So when we talk about kind of evaluating agents, part of it's just evaluate where the problem is going to come from in that sense too. Yeah, and so that gets to kind of one approach here of how you can kind of create a structured thing. And Vivo, I'm curious for your thoughts on this as well too, as we go through it. But a lot of times what we put forward is kind of a structured approach that you should take to evaluating an agent is to basically add that observability. So give that kind of view, build up a set of test cases that you're going to use, kind of your set of inputs, of types of inputs that you would receive on your agent, break down some of the different steps of your agent, and then create evaluators for either each step or just the important steps that could be more kind of evaluatable, I would say. And then if you have that test set and you have those evaluators consistent, you can kind of experiment and iterate through your agent, not just to fix issues, but also to kind of improve performance or things like that. And that gives you more of the benchmark to work off of.
Yeah, I like the general methodology, and I think we hear it a lot, but it's a little bit more nuanced, right? So how do I actually evaluate it? Like, let's say I've got each step, and one step is like, the amount, like the tool use, right? And let's say it uses 6 tools to get to the answer and the output is correct, but it could do it in 3 or could do it in 19. Now, each one, the output is correct, but like, how do I evaluate that, right? The one little thing you said there was track and evaluate each step that's important. My baseline, why not evaluate everything? Why not track everything? Build good system, right? So
Yeah.
Evaluate everything. You don't have to act on everything, but you should have good tracing and evaluations for every step. And then tying this together, now that you're at another dimensionality of it's another deterministic factor, not just deterministic in the output, but deterministic in the process, the tool use. There's times where it can get so like there might be a 6-step process that got to the right answer and used 3 tools. And there might also be a 6-step process that got to the right answer and used 2 tools. Well, if I've tracked both of these things, maybe I could run it, on 50 different samples, and turns out it fails 20% of the time with 3 tools and 80% of the time with 2 tools, right? So you might want to increase it a little bit to 3 tools. But point being, track everything.
Yeah. It's a good take as well. I think, if you can build the system well, you can create it so that you have those kind of tests for each different step, then you're going to have a more robust system, I would say, over time for sure. Yeah.
But I think that's just the specific answer on how to evaluate agents. But when it comes to like building an AI app or building a good system, I don't think you should over fixate on evals observability. You should heavy vibe check, LLM as a judge, eval, build a basic guardrail. Don't overcomplicate things at the start. So, ship quick and just ship it without good evals, because the other big thing is like, are you even evaluating the right thing? How are you end-to-end benchmarking this thing? Are you benchmarking it on a leaderboard, on main like MMLU benchmarks? Are you doing it on what you think users will use it for? Or do users even use it for what you think they're going to use for? So start out by just vibe checking and building it quick, then go back, add in this observability tracing, and then start to see what do people actually do for it, where does it fail, where does it do better, but also build it good at the start. Don't just build some trash and ship it. We don't want more trash, so build it good.
We don't need more Twitter demos. Yeah.
No, Twitter demos are great though. We need Twitter demos. That's what fuels good innovation.
Funding.
I mean, not just funding. Funding is part of it, but the other thing with Twitter demos is like a lot of what you see in a demo that works well once probably sparks like some fire in someone to go make it good, right? So like we were limited to very short context transformers. The BERT had 512 tokens, right? Base BERT was 512 tokens. They started to get to 2,000, 8,000. And then, someone did some hacky RNN that does decent, has like 1 million token context. And then, that sparked, hey, wait, we can probably work on this problem good, get long context, give people time after they saw the demo of a not so great LLM that had long context. Now Gemini's at millions of tokens, right? So Twitter demos are cool because once someone sees something possible, they might make it good. And then of course, do a good demo, raise a lot of money, burn some VC money, fail if you fail, or do it well. That's the other part.
John, I know we have some slides to get through, but can you go back to the router slide real quick? I just want to highlight one thing to the audience as we zoom out a little bit. A lot of people miss this.
This one?
Yeah, perfect. Okay, so if you're in the audience and you hear my voice, I think then we're talking about evals, and yes, we can do things like We can eval individual components, and that's maybe how we want to run an eval, or eval individual skills and look at the inputs and outputs of that, or even eval like the entire system and say, hey, did this user have a good session, this or that? We'll get into that in a second, but just don't forget, the whole point of all of this is to build some viable product to help your business out, right? Just remember, like I see this so much where people are experimenting and they have these like one-off questions and they're trying to optimize for X, Y, or Z. But just remember, like the main goal is to optimize for your business. So like a good example would be like Booking.com's trip planner, right? You can Google it, it's public information, but they built an agent that feels like a travel agent for their business. It provides revenue, it helps with them, booking, their services and beyond. So I would just like zoom out a little bit. I know we're kind of zoomed into like how agents work, how to evaluate them, but remember, like the long-term goal here is to build a viable product that helps the business. So just wanted to highlight that.
Yeah, always
I'll
good to
say the
keep that in mind.
opposite too, though.
Oh yeah.
So depending on what you're doing, right? Because not everyone does agents for businesses, right? There's also, you've got academics, you've got researchers. Sometimes, like, in that example of extending LLMs to long context, we had versions of attention that didn't do that well, right? Models that didn't do well to where you get it perform it. So let's say, you're a student, you're doing your PhD, and you want to work on an agent that can run for, 3 months nonstop and correct itself on track, right? If your one objective is to build an agent that can come back to track after an infinite amount of steps, well, you still got to look at the same evaluation suite. You just look at it in a different lens. So depending on what you're building, it might not always be a business objective, but
For
a
sure.
lot of this overlaps, right? Because a lot
Mhm.
of that is what gets transferred down into
Yeah.
enterprise stuff.
It sounds like you guys are saying similar things too, of just sort of keep the overall goal in mind when you come into evaluation. Don't get lost in just evaluating and for the sake of it, whether that goal is research or the goal is enterprise business value, whatever it is. Keep the goal in mind, basically, as you build these things.
Yeah, you can definitely tell we come from different spaces. So,
this is good. It's
go
exciting.
ahead, John. Yeah,
Yeah.
it's good.
Cool. I'm going to rip through a couple slides here just to show you guys some of these concepts, and then I want to make sure we cover the last few questions that we've gotten as well. I'm going to pass through some of these because this is material that's in plenty of other spaces within the Arise ecosystem around types of evals, like LLM as a judge and ground truth. Maybe we can share some of that in the follow-up as well too after this. So I'm going to rip through a couple of those. One I do want to touch on here is this concept of evaluating a router. So we talked about a lot of different ways that you can evaluate routers and evaluate the kind of steps agents are taking and things like that. But it is useful to kind of just highlight, if you've got a routing function, one of the easiest ways to start evaluating it is to focus on these 3 tasks that it has to do. Every time it gets some sort of input, it has to, number one, if it's going to go to a skill, choose the right skill to go to. So is it picking the right skill at that given moment, depending on the input that it's gotten? And then this, beyond just picking that skill, it's also got to be able to extract whatever kind of parameters are from the original input to populate that skills function call, essentially. So to put a concrete example of this, you've got a chatbot that can track orders and shipping orders. And someone writes in saying, hey, can you help me track my the status of my order ID 1234. It's got to know, the agent has to know to pick the tracking order skill, and then it's also got to know that the order 1234, that's an order ID, and it's got to fill that into the right parameter when it starts that function. So there's kind of the 2 jobs there: picking the skill and generating the right function, or extracting the right parameters from the query. And then there's also a step of generating the right function to actually go call and kind of generating the code for that. I'll say anecdotally from my side, I see most models doing that last step well almost all the time. I think it's more the parameter extraction and kind of skill choice where I see them running into a little bit more issues there. But again, we're kind of zooming into a particular area of routing here, or of evaluation here, which is just on that kind of router job. This is not to say the only kind of area that you can route, or evaluate. You can obviously evaluate all of the skills that are down the stream. And then you can also evaluate the overall flow of the agent, which is a lot of what we've talked about so far in the session. Cool. And then there's this idea of convergence, which is sort of what we talked about. This is almost more about the path of the agent. Is it making progress towards a goal? Could it do it in a smaller number of steps, or a lot of things that you've seen us talking about so far already in the session? So we won't go too much more in detail of that as an evaluation area. we have a bunch of questions that I want to make sure we can get through as well too. So unless there's anything you guys want to add, I'm going to jump through some of those questions. All right. So we have one asking if this is similar under the hood. Is this the same under the hood for old school enterprise using Salesforce Einstein? I'm not as familiar with Einstein, so I don't know if any of you guys are familiar with that as a kind of comparison point to some of the stuff we've talked about. Otherwise, we might have to follow up on that one.
Yeah, I think the way I understood Einstein's actually, it came out like 4 or 5 years ago. It's actually much older.
Yeah.
I always thought, I think it might be a little different. I'm sure they have added
So
like,
there's an update to Einstein. There was the 4 or 5 year old Salesforce
yeah,
Einstein. They
and they
have a new
updated it.
Copilot. I'm assuming he's asking about Copilot, but carry on.
Yeah, it's probably what they released at Dreamforce. So I wasn't sure because, old school enterprise using, but yeah, the way I was thinking about Einstein, I didn't go to Dreamforce, but I definitely know that it was all AI based. But is it the same under the hood for old school enterprises using? I'm not sure what it is what in context of, but Vibo, you can add anything you want on Einstein.
I don't know much about Einstein. I know the leads and the team at Einstein. They're smart people, but I haven't used it. I don't know how agentic it is, but smart people working there. That's all I've got to add. But I do
Yeah,
know that
Yeah.
they ship like an update. Einstein's now a Copilot. I haven't looked that deep into it. I think the thing that you have to remember in these is when a company like Salesforce builds an agent, it's a very general purpose plug and play, works for every customer of Salesforce, right? So in that sense, it's probably a decent like proof of concept gets the job done, but that doesn't mean you shouldn't explore with your own agent. Um, if you do it task specific for your industry, you can probably outperform whatever it is because they have to build a core abstraction that works for everyone, right? This falls into any framework. So if I've got a specific agent that just focuses on something, like I don't need a multi-agent framework. If I need specific observability and evals for one specific use case, I probably can make my own that's better than the platform. So same with the tooling that the products that these companies make, right? They have to work for everyone. If I have a specific use case, you can probably do better. But it also falls into the category of like, do you need an agent? A lot of tasks don't need to be agents. They don't need to be agentic. But I'm sure the rest of this series will cover, when to use an agent versus not. This is just on evaluating, but just something to consider because it's somewhat of an eval, right? I haven't need an agent, but I'm sure the rest of the series and other speakers will talk more on that.
Yeah, we touched on that in the first session that we did as well too. So if anyone missed it, there's a little bit about that. I'm sure it will come up in future sessions as well too. That actually, you touched on something there that touches on one of the other questions that we got as well too, which is around comparing models and kind of what are your thoughts about calling multiple models at the same time to compare results for accuracy and correctness, and then picking the best result. So you mentioned kind of mixture of agents as an approach. It sounds like it's sort of mixture of agents plus comparative kind of parallelized agents as well. Is that something that you've run across in your work?
Yeah, I think the first question is, what are your thoughts about calling multiple models at the same time? Well, one, I think, well, obviously the trade-off here is your increased costs. And if you're like trying to decide, hey, do I call Sonnet or let's use GPT-4 since O1 is like a different latency and maybe you need them to be somewhat near the similar latencies. I personally, this is my personal thought, like the only bias I see between models is like some tend to be more verbose in terms of output tokens than others. As an example, I'm sure there's other like model biases in there too, but for the most part, I don't really see that very often in the enterprise where people will call for a specific request to different models, but they might do things like model routing, where it's like you've ever used Light LLM or built your own kind of interface where they'll just call to a specific model based off cost, or sometimes they use performance. But so I don't see it as often as calling multiple models and doing a comparison like in generation. But for accuracy and correctness, we've done those benchmarks. I think, John, if you had that kind of in one of our slides of like, actually
Yeah,
we have in the Phoenix docs actually, but
yeah,
yeah, not all models grade the same, right? And so you're absolutely right. And when we think about like 3.5 versus like 4, again, there's a trade-off here between costs, for instance, latency, and then just performance of evals. And if you scroll to the bottom there, John, like, yeah, different models very much grade differently. And you can actually check to see how they do if you have some sort of golden data set. So that's my take on the first question. And then with the goal, what's your thoughts on calling multiple models with the goal to reduce error rate? I'm not sure about the mixture of agents, but I'd love to hear y'all's take, John or Vibhu, on that question.
Yeah, I'll chime in a little bit. So I think you're thinking about it right. These are all optimization steps you can do in your evals, right? So basic thing, if I want the best performance, why don't I run every query for any LLM system through, Foro, Gemini, Sonnet with a guardrail? If I could run it through Llama, run it through Mistral, run them through whatever, the first one that gives me a response and has the right answer, now you got to look at, okay, is it the total time for the response? Is it first token? Is it real time? Is it a guardrail check such that, if they both match the right answer, I'll proceed? It's all kind of a level of, it's a cool thought you're thinking about. Mixture of agents is good. Using a different MLE. Are you doing it for optimization? Is it for a guardrail? Why are you doing it? But it's the right thing to think about, right? But it's kind of like a secondary step. Once you've got a system that works, what are you trying to optimize? Do you want it to be faster? Do you want it to be a guardrail? Like, why are you doing it? You could do it. It's smart. You're building a good system if you're thinking about stuff like this. The one interesting note that we haven't touched on is with agents specifically, when it comes to looking at, how well do they perform? How many steps do they take? How long do they take? How many tokens do they use? How much does it cost? All that stuff. One thing that really differs between models is the specific prompts, right? So how are you storing these prompts? How are you evaluating it? Because oftentimes, if I've got an agentic system and if I just swap in Llama 3 and swap out to Mistral to Sonnet to Gemini, you often have to heavily tune the prompt. So if it's something basic, like, an LLM call that just few shots, 0 shots of summary, you can probably swap a model. But in these more advanced looping systems where you've got agents that take steps and planning, use tools, you probably need pretty verbose descriptions. And all models have their strong suits, right? So Sonnet might be a little better at coding. Some of them might be more verbose in their summary responses. Some might be more concise. Some might follow tool uses better. Some might parse outputs better. So for each model, you might need to also adjust different steps of the prompt. So when it comes to stuff like this, it's a good guardrail, it's a good vibe check. It's something you can do when you build a system and you prototype, but you have to do it right. And there's a lot of factors to consider there. So a high level, what are my thoughts on it? If you do it all right and you consider all that, you can build a pretty good system. But consider all those things well and just think of why you're doing it. Don't over fixate on all these, like, I want to build an MOA, I want to swap in models and do all that stuff at the start. Build it right first, because you'll also realize, like, what are you optimizing for? Your assumptions are probably wrong. You might think, send out 3 responses, get the first one that streams a token back, but your actual UX might be a user that's like, I understand this is an agent and agents take some time, and I'm okay with, letting it run for 10 seconds if that's a better response. So all that stuff.
Yeah, and then just to highlight that, I think I know we are covering like some deep parts here, but yeah, I think nothing ever beats simplicity. If you can do something as simple as possible, and Vivu is going to argue with, like, if you can get away with simplicity rather than
Heavy
complication,
disagree.
yeah, we can disagree. I think if you
No,
can
no.
get away with something and it's simple, that's a much better solution than over engineering something that like you didn't need to do, right? You're like, to me, I'm in the enterprise, I'm always just optimizing time to value, right? What's like the least amount of effort to get the thing that I want done? And maybe on the research side, it's different. Maybe it's exploration for exploration's sake and or some sort of breakthrough, which again, we would have different paradigms, but that's just one thing from my perspective.
I'll give you the quick counterexample. It's not research side, right? You want to over engineer the very best solution that does one thing that no one else does, and you blow up on Twitter and you raise a lot of VC money and you burn it. You need the best of the best over engineered. But in all seriousness, no, I think you should keep things simple. Especially in, like, the crew that's probably listening to this webinar, the advancedness of stuff like, should I send it to multiple models as a guardrail or a quick vibe check? in reality, most systems are still over engineered, like LLM as a judge, all this stuff. It's way overkill for what you need. There's still a lot of adoption that hasn't been made where you can provide a lot of value with a very simple, basic, reliable system. The more advanced and complex you make it, the more complex your observability eval suite and reliability of this thing becomes. So actually, make a good system that solves a useful problem simply, or go all out, burn some VC money, build a complex thing that does something good once, and show you could do it. So
Yeah.
fit in one camp, and go all the way. Don't half-ass it.
Amazing. Well, on that note, we are out of time, so we have to wrap it up. If you're looking for the most simple to set up observability solution, check out the box on the right of here. We have Phoenix as our open source tool, and then you guys can always try out some of the agent evaluation tools that we have in Arise. On the left side, you can sign up for a free account there. If you're liking Phoenix or you like the content of the webinar, please consider giving us a star over there on that GitHub repo. It's always helpful for us. Big thank you to you for joining the session. This was really fun, great conversation. And is there anything that you want to share as we wrap up here?
Yeah, always fun stuff. Check out Phoenix. Make it good and contribute. It's open source. We need contribution. Make it better if you think something's missing in there. I'm hypocritical. I should make it better if there's stuff I don't like in it. But I do like it. Improve their docs. I'll roast a little bit. Check out the rest of the series though. It's always fun with these guys. Make their docs better. Get me a good quick start.
Awesome.
I know. Yeah.
All right.
Thanks, guys.
Thank you, everybody.
Thanks,
Have a
everyone.
great rest of your day.
Cheers.
Bye.